1 minute now, guys. Sorry. Apologies, sorry. People are waiting in the lobby. Admit all. Nabila and Sharifa, welcome. Is it broken? Just about now, say, okay. It has to be hardware. Oh my God, sebab ni ke? Okay, boleh lah. Something is still wrong, but okay. Aisha, our 17th attendee. Okay, so I was saying, last week kita dah go over chapter gas. So dalam chapter gas, the main topics yang kamu mungkin perasan adalah the gas law. Kan, gas laws. So dalam gas laws ni kita tengok the three gas law, iaitu kita ada Charles law, kita ada Boyle's law, and kita ada number 3, kita ada Guy-Lussac's law. Okay, so dalam in three of this law basically adalah satu mathematical equation that kita boleh guna untuk describe the behavior of gases. Gas ni punya apa? Gas ni punya pressure, volume, dia punya temperature, all of these things, dan dia punya bilangan mole, all of these things akan affect dia punya behavior. So behavior ni kita boleh discuss lah, sama ada dia punya dia dimampatkan ke, dia punya isi padu bertambah ke, dia mengembang ke, dia mengecut, itu maksudnya dimampatkan ataupun tidak lah. Okay, so untuk describe all of this behavior of gas ni, kita boleh gunakan all this gas law, Charles law ke, Boyle's law ke, ataupun Gay-Lussac's law. And all of these are just mathematical equation, math formula used to describe the behavior of gases. Because the behavior of gases, sifat-sifat sesuatu gas is affected. It will be, oh sorry, silap eja. Dia akan dipengaruhi oleh pressure, tekanan. Dia akan dipengaruhi oleh volume, isi padu. Dia akan dipengaruhi oleh suhu, temperature, and also dia punya bilangan mole. Kalau kita, the examples that we have gone through last week adalah macam kalau kamu, if you remember dalam the quizzes lesson, if you take a basketball, you leave it outside overnight dalam suhu yang semakin sejuk, pada keesokan paginya, bola tu akan mengempis. Dia akan bukan mengecut dengan banyak, tapi dia akan jadi macam kurang angin. So why is that? This is because the gas that is inside the ball, because of its exposure to low temperature, suhu yang rendah, suhu yang sejuk, dia punya gas yang dalam tu dia mengecut, dia dimampatkan. The volume is decreased because the temperature is reduced. So that is Charles' law described, because dalam Charles' law, volume is directly related to temperature. So as the temperature goes down, the volume will also go down. Kalau dalam Boyle's law, it describes the relationship between pressure and volume, which is, what's the word? Indirectly proportional, P and V. So as the pressure goes up, volume goes down. Okay? So this is how we use all these gas law, Charles' law, Boyle's law, and Gay-Lussac's law. Kalau dalam Gay-Lussac's law, it's pressure and volume directly related. As pressure goes up, volume goes up also. Kalau pressure goes down, that's not good. So kalau pressure goes down, volume also goes down. So this is the same applies. This logic applies untuk Charles' law dan Boyle's law. Kalau volume, kalau untuk Charles' law, if the volume of the gas goes down, the temperature also went down. Okay, and vice versa. It's related. That's the relationship. Tira, DPH 43, welcome. Okay, so the behavior of gases ni dipengaruhi oleh pressure, volume, dan temperature, dan also bilangan mole. This is because kalau kita cakap tentang bola tadi. So this is a ball. Dalam dia dipenuhi dengan gas molecules. We pump bola dengan angin. Before we can play any sports using the ball, kita nak dia penuh dengan angin, so that it will function as it's supposed to be. Okay, so these are gas molecules. So kalau kita cakap tentang gas, kenapa dia dipengaruhi oleh pressure? Why is it affected by pressure, temperature, and volume? We have to know first. So in order for you to understand the behavior of gases, you have to understand how the structure of the molecules ataupun the atoms of these gases. Katakanlah, for example, you take oxygen gas. Oxygen gas only. Kamu masukkan dia dalam bola ni. So these oxygen gases, dia terikat antara satu sama lain, the molecules. Okay, O2, this is the molecule. Molecule of oxygen. Oxygen gas. So dalam bola ni, we are talking about molecules of O2 gases. So dia ada O2 molecule dekat sini, O2 molecule dekat sini, O2 molecules, another O2 molecules. It is filled. The ball dipenuhi dengan molecule gas oxygen. So kat sini saya nak cerita sikit tentang how are they terikat antara satu sama lain. Because things exist, matter exists, sesuatu benda, sesuatu bahan itu wujud kerana molekul-molekul dia terikat antara satu sama lain, ataupun atom-atom dia terikat antara satu sama lain. This is how we have stuff. I'm holding this pen. Maybe kamu tak nampak saya. Kita boleh pegang sesuatu benda. We can touch certain things because atom-atom dia, molekul-molekul dia terikat antara satu sama lain. So this pen that I'm holding, this is a solid. So dia punya susunan tu, the molecules, the atoms of the substance of this pen terikat dengan rapat antara satu sama lain. So dia ada bentuk yang tetap. If you are holding your phone right now, the atoms, the molecules of the substance that is that phone terikat dengan rapat. Okay, dia disusun dengan cantik, dengan rapat, arranged nicely, tightly packed antara satu sama lain. So it can have a shape, it can have a form. Bentuk dia tetap, dia punya isi padu dia tetap, tak berubah. Kamu boleh change the shape of your phone, but you have to break it. Kamu perlu patahkan dia ataupun pecahkan dia. Okay, pen ni pun sama. I can change the shape and the volume, but I have to break it apart. The molecules of liquid is different. It's a bit more loose, but it is still tightly packed. So gas is even more loose. That's why gas tidak ada bentuk yang tetap. Dia tidak ada isi padu yang tetap. Okay? It does not have a fixed volume. It does not have a fixed shape. Kalau kamu ambil amount of gas, kamu masukkan dia dalam bola, the volume of the gas is the same as the volume of the ball. Kalau kamu ada bola yang besar, katakanlah dalam bola keranjang, katakanlah the volume of the bola keranjang is 2 liter. Okay, ruang dalam bola tu adalah 2 liter. So if you put any amount of gas in that ball, the volume of the gas will be the same as the volume of the ball. Kalau kamu take the same gas that is in the 2 liter ball, you take that amount of gas, masukkan dalam bola yang kecil, bola tenis for example, small, you can put air inside bola tenis. It's not possible. Kamu masukkan dalam bola sepak pula, it's a bit smaller. Bola sepak is a bit smaller than bola keranjang. Katakanlah boleh masukkan 1 liter. So now the volume of the gas that was once 2 liter, it is now 1 liter. Okay, so the volume of the gas is equal to the volume of the container that it is in. So why is that? This is because the ikatan, the intermolecular forces. Ini dalam topik kinetic molecular theory. So kalau kamu nak baca dalam buku rujukan yang ada dalam ITEL yang saya share tu, this is the topic lah, kinetic molecular theory of gases. So in gases, what does typo pula. Apakah maksud kinetic molecular theory? This is just a fancy word untuk menceritakan bagaimana atom-atom ataupun bagaimana sesuatu molekul of a gas bonded to each other. Okay, they are bonded through intermolecular forces. Intermolecular forces. Ada ikatan yang mengikat molekul-molekul oksigen ni. That's why dia exist as a gas. Ada ikatan yang lemah, dia tak kuat, tapi it's still bonded to each other. But because it is very very weak, dia boleh move around dengan bebas. Bukan macam solid, pepejal. Kalau pepejal, dia disusun dalam lattices, dalam bentuk solid. Kalau if you have a cube of anything, katakanlah this is a block of wood. If this is a block of wood, the atom of carbon inside this block of wood is tightly packed. You imagine these circles are the molecules or the atoms of the wood. So it is tightly packed to each other. Dia punya ikatan tu sangatlah kuat. So it form a certain shape. So for this block of wood, the bentuk cube. So this is the kinetic molecular theory of solid. This is kita panggil sebagai amorphous solid. Okay, kita ada dua jenis solid yang kita belajar, amorphous dan juga crystal. Crystal is a bit different. Amorphous ni macam ni. Okay, so this is the kinetic molecular theory of solid. Dia menceritakan bagaimana ikatan antara solid tu, the atoms, ikatan antara atoms dan juga the molecules of a solid is very very strong. It's tightly wounded, tightly packed, That's why it formed a certain shape. Okay, but the kinetic molecular theory of gases is like this. It is very very loosely bonded. So therefore, it can move around freely, but still within the bounds of the ikatan of the intermolecular forces. Okay, terikat antara satu sama lain. Okay, there are names untuk intermolecular forces ni, but for now, just focus on understanding that there are ikatan. There is a force. There is force that binds the atoms ataupun the molecules of gas. Ada kuasa yang mengikat atom-atom dan juga molekul-molekul sesuatu gas tu. Kalau ikatan antara atom dan antara molekul ni hilang, maka sesuatu bahan itu tidak akan wujud lagi. Okay? So that is the meaning of kinetic molecular theory. So once we have understood this intermolecular forces antara gas ni, barulah kita boleh faham why kenapa dia tak mau pergi. Kenapa sifat-sifat gas tu dipengaruhi oleh pressure, dipengaruhi oleh temperature dan juga volume. Okay, tekanan bila kita ada satu balon, kamu dah tiup angin dalam balon tu, kamu picit balon tu, dia akan pecah. So kenapa dia pecah? Because you applied pressure, okay, tekanan tu terlalu tinggi, the volume of the gas is now changed. Dia cuba kita describe sekarang ini relationship antara pressure dan juga volume, which is Gay-Lussac's law. So if you have a balloon, this is a balloon, ikat dia dalam ni ada, katakanlah kita isi dengan helium. Okay, balon helium. Helium, penuh dengan helium atom dalam ni. Helium. So, kalau kita picit balon ni, if you apply pressure, okay, if we apply pressure to the left, you take your right hand, you take your left hand, you apply pressure, kamu picit dia. So, lama-kelamaan, the volume of this the volume of this gas akan meningkat. Okay, so when the volume increase, the volume will also increase. So when there's the volume increase, tapi space semakin kurang because kamu dah picitkan dia. So lama-kelamaan balon tu akan pop, pecah. So bila kita picit dia, helium. So this is pressure here. Pressure. So there's no space for the increase volume to go. Maka lama-kelamaan dia akan pop, pecah. So this is an example of describing the relationship between pressure dan juga volume of a gas. Okay, because of dia punya ikatan antara atom tu terlalu lemah, it can move around very freely. So kita boleh apply pressure dengan mudah. Kalau if you take a solid for example, you take a block of wood, kamu try apply pressure to it, boleh tak? Can you break it apart by just taking a block of wood? Kamu tekan dia dengan tangan kiri dan tangan kanan kamu. You cannot because solid is not as easily compressible as gas. Because the kinetic molecular theory of a solid is tightly packed. Dia punya ikatan antara atom-atom dan juga molekul sesuatu pepejal itu terletak, diikat dengan sangat rapat. Kita tak boleh nak picit satu blok kayu semudah kita picit sebiji balon. Because it doesn't work that way. So that's why kita kena faham kinetic molecular theory. Bagaimana sesuatu bahan itu, dia punya structure of a substance is made up, is built up. Okay? So, bila kita dah faham tu, kita boleh apply, kita boleh describe the behavior of gases menggunakan Charles' law, Boyle's law dan juga Gay-Lussac's law. That's the purpose of kamu belajar tentang Charles, Boyle's and Gay-Lussac's law ni. Kamu nak describe the behavior of gases bila dia dipengaruhi oleh pressure, temperature dan juga volume. Okay, so if you have problems understanding apa benda itu Charles' law, Boyle's law dan Gay-Lussac's law, try to understand that first. Okay, gas, kita mulakan dengan gas, sesuatu bahan tu. kita kena faham dulu, how are the atoms and molecules are arranged. Kalau gas, dia bergerak dengan bebas, tapi masih ada ikatan yang lemah. Kalau liquid, the ikatan, the bond between the molecules and the atoms are a bit stronger than gas. So that's why dia ada isi padu yang tetap. The difference between gas dan liquid adalah liquid ada isi padu yang tetap, gas tidak ada isi padu yang tetap. Kalau kamu ada botol air 1.5 liter, kamu cuba isikan 1.5 liter air dalam botol 0.5 liter, tak boleh. Akan tertumpah. Okay, because tidak ada ruang yang cukup untuk air tu ditadah. Tapi if you have a 1.5 liter of gas in a 1.5 liter container dan kamu tuang dia dalam bekas yang lebih kecil 0.5 liter, semua 1.5 liter gas tu boleh masuk dalam 0.5 liter container. Because of the structure of gas is very loose, dia boleh mengembang dan mengecut dengan lebih mudah berbanding dengan liquid. That is the difference between liquid dan juga gas. Solid, it's more tightly wounded, tightly packed. Dia ada definite shape, dia ada bentuk yang tetap, dia ada volume yang tetap. Okay, so dia naik satu level lagi daripada liquid. Okay, so in terms of dia punya arrangement between gases, liquids dan juga solids ni, dia punya compressibility, keboleh tekanan increase. Okay, decrease. Kita boleh apply a lot of pressure to gas. Kita boleh apply less pressure to liquid and a lot less pressure to solid. Kita boleh pecahkan satu blok kayu, tapi kita kena apply a very, very high pressure. You can break a block of wood. You take a tool like an axe, for example, kamu kena hentak dia, barulah dia pecah dua. Okay, so a lot of pressure, a lot of force needed to break a block of wood compared to just you cannot have a block of gas. Tapi that's the thing lah. Okay, because of the solid is more dense, lagi tumpat, dia ada lagi banyak bahan dalam one block of wood than just a 1 liter of balloon. That's why solid lebih susah untuk kita apply pressure and solid is a lot easier. So once you have understood that, the rest of this chapter adalah just the mathematical equation. Kita nak solve problems using Charles' law, Boyle's law dan juga Gay-Lussac's law. I think my pen ada problem. So let's take blue. So macam saya kata tadi, untuk Boyle's law, kita ada equation P1 V1 equals to P2 V2. Untuk Charles's law, kita ada P1 and T1 equals to P2 and T2. Dan untuk Gay-Lussac's law, we have, saya tulis GL lah, okay? Gay-Lussac's law, kita ada T and V, sorry. T1 V1 equals to T2 V2. Okay, so if you have basically, kalau macam untuk Boyle's law, dia describe relationship antara pressure dan juga volume. So if let's say I say dalam satu bekas, pressure and volume, yes. The one example yang kita go through last week, we have a container, katalah. Okay, container ni tertutup. It's a closed system. Kat atas ni ada satu piston. So this is a piston. And inside this container ada O2 gas, O2 oxygen. Okay, so katakanlah initially volume V1 is 2 liter. And the initial pressure is 1 atm. ATM is the unit untuk tekanan. Oh, sorry, saya kena tulis. Let's practice over here. So P1 equals to 1 atm. So let's say, katakanlah, we apply more pressure. Kita turunkan this piston. We bring it down. Kita apply tekanan. So that means you imagine, you can draw. Masa saya student dulu, kalau saya dapat problem macam ni, I always draw because I'm a very visual person. So kalau dia kata the piston is lowered, kita turunkan dia. So now we can see, saya boleh nampak, there's a lot less space. Ruang semakin mengecil. So that means the volume is reduced. So kalaulah kita increase the pressure, P2 jadilah 3 atm. 3 saja susah-susah. Nombor ganjil. Saya bagi nombor genap. 2 atm. And now saya nak tahu V2 equals to what? What is it? Because now all the O2 molecules dah cramp up, compressed, ditekan. So the volume, we can see there is a lot space here. Tapi sini dah makin mengecil. But we want to know exactly how much is it. So we can use Boyle's law because this is a situation that shows the relationship antara pressure dan juga volume. So according to Boyle's law, P1 V1 equals to P2 V2. Itu maksud 1 and 2 tu. Initial and after. So 2 is after lah. After we have changed the pressure. Kita dah lower the piston. Now the pressure is increased daripada 1 kepada 2. So kalau kita increase the pressure, the volume, what will happen? So here kita tengok. Kalau P1 V1 equals to P2 V2, kita nak cari V2. So kita arrange this equation so that V2 is our unknown. So that means P1 V1 divided by P2. Now you just fill in the blanks. P1 kita dah ada, V1 pun kita dah ada, P2 also kita ada. So it will be 1 atm multiply V1 2 liter divide by P2 2 liter. Okay, so now kita just solve this equation lah. So 1 darab 2, ni cancel, jadi 2 bahagi 2. Bagi 2 equals to 180. Sorry, saya silap unit ni, ATM ni, 2 ATM je. ATM, P2, pressure is ATM. So ATM potong ATM, so jadilah 2 bahagi 2, jadilah 1 liter. Ada unit liter kat sini. So the V2 equals to 1 liter. So you can see here, the volume is reduced daripada 2 sampai jadi 1. So that perfectly described dalam Boyle's law, pressure is indirectly proportional, berkadar songsang. Meaning as pressure increases, volume akan semakin menurun. So this is what happens here. Kita increase the pressure daripada 1 kepada 2 atm. So now after we have calculated, the volume reduce. Dikurangkan daripada 2 jadi 1 liter. Okay, so as we increase pressure, tekanan kita naikkan, the volume reduce. So it is proven by our calculation here. So just that logic kita boleh apply untuk all the other law lah. Boyle's law, Charles' law dan Gay-Lussac's. Dia akan describe, you will come to a problem. Dia cakap initially the pressure is so and so. The volume is so and so. The temperature is so and so. So find the final pressure. What is P2? What is, please find V2. What is it? Please find T2. What is it? Okay, untuk dalam gas law, this is dia punya application. Kita nak cari the value of pressure, volume dan juga temperature after a certain change has been applied. Kita naikkan temperature ke, kita turunkan temperature ke, kita naikkan volume ke, kita rendahkan volume. So all this can be calculated using Charles' law, Boyle's law dan juga Gay-Lussac's law. But the trick is kamu kena faham untuk each of this there's a specific condition. Okay, ada beberapa. Macam mana kamu nak tahu? Katakanlah, macam mana saya tahu untuk ni? Untuk this problem tadi ni, macam mana saya tahu saya nak pilih Gay-Lussac's law? Apa color yang ni sikit? Macam mana saya tahu saya nak pilih, Charles law? How do I know this is Charles law? Sorry, my bad, Boyle's law. Saya pun dah confused lah. How do I know it's Boyle's law? How do I know? So macam saya cakap tadi, kita tengok what has changed. So kita dah identify this is, benda yang kita ada adalah pressure dan juga volume. Okay, before and after ada pressure and volume. So what is not mentioned here is temperature. Temperature does not change. It is constant. So untuk each of this law, dia ada this condition. Ada some variable yang constant. Untuk Boyle's law, apa yang constant adalah temperature. Untuk Boyle's law, temperature constant. Untuk Charles law, it is volume yang constant. Untuk Gay-Lussac's law, pressure yang constant. So this is the key thing yang kamu boleh guna untuk identify a certain problem. Which law that is best describing what is happening. Kalau kamu nampak satu problem tu, you read it, kamu tengok, okay, dalam problem ni, temperature is constant, it does not change. So kita boleh guna Boyle's law. So if you read another problem, dia kata, okay, volume does not change. Only pressure and temperature is changed. So kalau volume does not change, that means kita boleh guna Charles law to solve this problem. The same untuk Gay-Lussac's law. Kalau pressure is constant, kita guna that formula untuk solve that problem. Okay, so that is how you apply this gas law nama dia. Boyle's, Charles and Gay-Lussac's law. Just a tool untuk kita solve problem involving gas. And one last thing, one last law yang kita tak sempat go over last week adalah the ideal gas equation, the ideal gas law. So dalam ideal gas equation ni, dia combine all three Charles, Boyle's, Gay-Lussac's and Avogadro formula yang kita tak masuk dalam syllabus kita ni. So dalam ideal gas equation, this is the formula. They describe the relationship between pressure, volume, bilangan mole, a gas constant, dan juga temperature. So this is known as the ideal gas equation. Kita boleh solve a problem involving a gas once we have obtained dia punya pressure, volume, bilangan mole, dan juga temperature. R is a constant. Maksudnya dia pemalar, value dia tak berubah. Untuk kita punya syllabus, the value of R equals to 0.082. Satu unit dia adalah liter ATM per mole Kelvin. So that means the unit untuk pressure mesti dalam ATM. The unit untuk volume mesti dalam liter. The unit ni untuk N adalah mole. The unit untuk temperature adalah Kelvin. So if let's say if I have a problem, katakanlah we have a gas in a container, the pressure is 1 atm. The volume is, let's say, 2 liter. Bilangan mole is, let's say, 1 mole. Oh, sorry, I missed. Mole is 1. And can you find the temperature? So if we have a problem like this, let's say this is a container, instead there are oxygen. Oxygen. So from this statement, kita tahu pressure is 1 atm. Volume is 2 liter. Kita ada 1 mole of oxygen gas. So can you find the temperature? Can you predict the temperature that we have inside this? What is it? So kita boleh guna PV equals to nRT. So write down PV equals to N, R, and T. So once we have all the value here, kita nak cari temperature, so susun. Jadikan T as our unknown. Arrange the equation, arrange the formula so that T is our unknown. T equals to PV divided by N and R. So kita fill in the blanks. Pressure is 1 atm. multiply by volume, which is 2 liter, divide by N, which is the number of mole, 1 mole, darab dengan R, which is a constant, 0.0821. So 0.0821, the unit is liter ATM per mole Kelvin. So the temperature, the unit untuk temperature mesti dalam, macam saya cakap tadi, mesti dalam unit. So solve the equation. So 2 liter ATM bagi dengan 0.0821 liter dot ATM divide by Kelvin. Unit mole ni dah cancel by this one. Dia dah bahagi dah. Okay, that's tak ada. So now kita boleh tengok unit apa yang tinggal. So ATM divide by ATM cancel. Liter divide by liter cancel. So the final unit will be in K. So you take your calculator, 2 bahagi dengan 0.0821. The unit will be K lah. 1 K. So you get a certain value which is X Kelvin. This is the purpose, this is the application of ideal gas equation. So dalam this, if you notice, dia bukan macam dalam gas law tadi, dia tak describe before and after. Okay, dia describe keadaan yang berlaku sekarang. I have a container, dalam container ni ada O2 gas. Kita tahu pressure is 1 atm, volume 2 liter, bilangan mol kita tahu. Saya nak tahu temperature kat dalam bekas ni berapa. So the application of this ideal gas law ni, katakanlah if you work in, if you're an engineer ataupun you're a pharmacist, kamu nak formulate sesuatu ubat. Kamu kena formulate sesuatu ubat tu, kamu mesti grind ataupun compress dalam satu machine. So you want to know, you want to maintain the temperature inside the machine is supposed to be the most is 30 degrees Celsius. So theoretically kamu boleh predict kalau kamu nak sediakan satu proses yang tertutup di mana temperature sesuatu dalam sesuatu bekas tu terkawal 30 degrees Celsius. So kamu boleh guna PV equals to nRT untuk so that you can control. Pressure mesti within this amount. Volume mesti this amount. Bilangan mol mesti this amount. So that the temperature will remain at 30 degrees. Kamu boleh control this. This is the purpose of ideal gas equation. Dia tidak ada, kita tak, we are not talking about before and after. We are not making a change. We are talking about a closed system. Everything is happening in that one system at that moment. Kita bukan cakap tentang before and after macam Boyle's law, Charles law dan gas law. Tadi ada P1 V1 equals to P2 V2, bukan. In PV equals to nRT, most of the time kita akan guna untuk solve problem in that moment only. Ada juga dia boleh guna untuk before and after, but that is a different set of problem. Okay, kita akan tengok when it comes in the tutorial ataupun apa nanti. Ada satu soalan macam tu dalam your group work, gas law group work. So try to solve that kalau nanti kita akan discuss. Okay, so this is basically dalam chapter gas. So that will bring us to today's lesson, iaitu, oh, mouse saya dah disconnected. Iaitu liquid. Do you have any questions so far tentang gas? Sebab minggu lepas laju sangat, saya takut kamu blur ke, kamu lost ke. Kalau kamu blur, kamu lost, kamu segan nak tanya, try buat tutorial tu dengan kawan-kawan. So kalau kawan-kawan kamu boleh buat, kamu tanyalah dia. Kalau kamu segan nak tanya saya. But if kawan-kawan kamu dengan kamu pun blur, tolong tanya saya lah. Okay? Otherwise, nanti kamu sampai bila-bila kamu lost. Kalau kamu tak tahu lagi, saya tak sure saya announce ke tidak. Saya tak announce kan? Because dalam ni, mana ada? Chapter 4, topic 4. Okay, ada another group work, gas law problem. So kalau kamu go over to your ITEL, I'm sharing my screen kan. If you go over to your ITEL, kamu klik in topic 4, dekat bawah ni saya baru post last week. Gas law problem. This is a group assignment. Allah, my bad, sorry. So group assignment. Dalamnya ada 5 soalan essay, short essay question. Mana dia? Dalam PDF ni. So if you click on this, kamu akan nampaklah that 5 questions. Tapi kamu buat dalam group. So you get into your infographic group tu, the same group, kamu bincang together macam mana nak solve the problem. And then you write it down dalam Word, the solution. Tunjuk jalan kerja. I forgot to include that here. Tunjuk jalan kerja macam mana, macam saya buat ni lah. Okay, jalan kerja. Kalau P1 V1 equals to P2 V2, tulis. Kalau nak cari volume, susun V2 as your unknown. Sorry, I forgot again. Saya share screen kat sini. Aduh. Okay, buat jalan kerja macam ni. Kamu boleh tulis guna Word sahaja. Kalau kamu nak tulis atas piece of paper pun no problem. Ambil gambar and then convert to PDF and then upload dalam iTel. Okay, I don't have any problem with whatever media kamu nak guna, whatever software app kamu nak guna. Janji in the end kamu upload dalam bentuk PDF, kemas, saya boleh baca, saya boleh tanda, saya boleh check your work. Okay. So kamu boleh tulis, kalau nak solve a problem, tulis formula. Kalau dah identify, this is Boyle's law, nak guna untuk solve the problem, Boyle's law. So tulis P1 V1 equals to P2 V2. So kalau nak cari V2, jadikan V2 as your unknown, and then arrange macam ni cantik-cantik, dan tunjuk 1 darab 2 bagi 2, and the final answer. Okay, so bincang dalam group, macam mana nak buat. So the purpose kenapa saya buat ni as a group question, so that kamu boleh, kalau ada 4 orang dalam grup, ada 2 orang tak faham dan 2 orang faham. So the 2 person yang tak faham tu, kamu tanya kawan kamu. Saya nak kamu faham. Saya nak kamu discuss between amongst yourself, so that kamu faham, you can learn from your peers. Kalau kamu macam segan nak tanya saya, ataupun kamu consider saya as your last resort, tanya kawan dulu, discuss dengan kawan. Okay? That is on iTel. Ada 5 soalan, short essay question. Ada 10 markah, that will be a part of your grade lah. Okay, meaning saya akan gunakan ini untuk grade kamu nak dapat. This is 10%. Okay, so 10% from 100%. So work together lah. Okay, ada 4 orang, 3 atau 4 orang dalam group. Ada group yang 2 orang kan, saya ingat. Okay, so kalau 2 orang tak faham, please tanya saya. Bila dah siap, macam saya cakap tadi, convert dalam PDF. Kalau kamu buat dalam Word document, save dalam PDF, export dalam PDF, convert, submit, upload kat dalam iTel ni. Kalau ada orang submit dah. So kalau kamu tulis dalam paper, kamu tangkap gambar, you take a picture of that paper. Wait a minute, ada kawan kamu. Guys are waiting in the lobby. Ayuni Shafrina. So kalau kamu buat dalam kertas, take a picture of that paper, convert to PDF and then upload. Sama juga in the end. Okay, tolong upload dalam PDF so saya boleh tanda markah. Alright. Let's go back to the lesson. Okay, so last week kita dah go over gas and solid. Today in the new chapter, chapter 5, kita nak tengok liquid and solutions. So dalam this chapter, sama macam gas tadi, kita akan discuss tentang dia punya kinetic molecular theory. Kita nak tengok the susunan of the atoms and the molecules of liquid. Kemudian kita akan discuss pula dia punya properties of liquids. And then kita akan tengok solutions. What are solutions? What's the difference between liquid dan juga solution? And bila kita dah faham solution, kita akan tengok solubility. Okay, what is solubility and why do we need to understand it as a pharmacy student? And then the final 2 adalah introduction to colligative properties. So in this lecture, by the end of it, you should be able to explain the properties of liquids. You should be able to identify the different types of solutions, explain the process of a solution dan juga solubility, and describe the colligative. What is colligative properties and explain a bit about colligative properties. So the 4 key things that you should come out of that you should have by the end of this chapter. Okay, so the first things first, kinetic molecular theory. Macam saya cakap tadi, in a liquid, the molecules are close together. Kalau kita bandingkan dengan gas, dia punya ikatan, dia punya atom disusun dengan lebih rapat berbanding dengan gas. So, ada less empty space. Kalau dalam gas, ada banyak ruang yang kosong because atom-atom dan molekul gas tu bergerak dengan bebas. Okay, it can go far apart from each other. That's why liquid dia ada definite volume. Dia ada volume, dia ada isi padu yang tetap. The molecules can move past one another freely. So liquid boleh flow, dia boleh mengalir, kita boleh tuang dia, and the shape is the same as the container. So therefore, because of this, the arrangement of the atoms and the molecules, liquids are much more difficult to compress than gases. They are also much denser, lebih tumpat under normal conditions. So this is a table that basically describes, dia dah summarize dan ringkaskan apa yang saya cerita panjang-panjang tadi. So kita ada 3 different state of matter, 3 substances, gas, liquid dan solid. So kita boleh bandingkan, kita boleh tengok the difference between dia punya volume and shape, dia punya density, dia punya keboleh tekanan, compressibility, dan juga the motion, pergerakan molekul sesuatu bahan itu. So kalau gas, the motion is free, very free motion. The molecules of gas bergerak dengan bebas. Liquid, a bit less free. It slide past one another dengan bebas. Tapi solid, dia bergerak but in the form of vibration. Dia bergetar. It vibrate about fixed positions. Dia bergetar dalam keadaan yang tetap. So all the solid that we see, the chair that we sit on right now, dia bukan duduk diam. The molecules of the chair that I'm sitting on right now is vibrating at a very low vibration. Okay, so because of the density of solid, because of the density is high, ketepatan dia tinggi, susah untuk kita apply pressure. Virtually incompressible. Kalau liquid, only slightly compressible. Gas sangat mudah untuk kita compress, untuk kita apply tekanan. So this is basically the kinetic molecular theory, the results of the kinetic molecular theory of gas, liquid, dan so dia menggambarkan what is the result of kinetic molecular theory of gas, liquid, dan juga solid. So dalam solid, macam saya cakap tadi, kalau dalam gas, the intermolecular forces is very weak. That's why dia bergerak dengan bebas antara satu sama lain. So kalau dalam liquid, kita boleh discuss dengan lebih dalam lagi because kita boleh study dia dengan lebih lengkap, dengan lebih mudah. Kalau gas is a bit susah untuk kita conduct an experiment compared to liquid because dia punya ikatan sangat lemah. That's why dia punya pergerakan sangat bebas. Tapi kalau liquid because walaupun lemah tapi it's measurable, kita boleh ukur dia. So in experiments, that is the key thing, kita boleh ukur. So once perform multiple hundreds and thousands of experiment has been conducted, kita identified a couple of intermolecular forces. So kat sini saya nak kamu boleh bezakan antara intermolecular forces dan juga intramolecular forces. So kalau intermolecular forces, dia adalah forces that are attractive forces between molecules. Kalau intramolecular forces, it holds the atoms together in a molecule. So kat sini, saya nak describe. Mana saya punya pen ni? What does that mean? Astaga. Saya dah buka. Okay. So apakah yang dimaksud dengan intramolecular forces dan juga dengan intermolecular forces? Oh, I forgot again. Sorry guys. Saya kena change screen. So dalam intermolecular forces macam saya tulis tadi, dalam intermolecular forces it describe the forces that is between molecules. Kalau intramolecular forces, it describe the forces between the atoms of the molecules. So kalau saya ambil contoh macam air, water. Everybody has seen water kan. If you go to your kitchen right now, kamu pergi dekat sink dapur, kamu buka air, kamu buka apa nama? The pipe dapur, kamu tadah. So you have this glass of water. So inside this glass of water, so inside this glass of water, there ada O2 molecules. O2, 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 O2. So apa yang kita like take for granted adalah kalau kita tak boleh nak visualize, this O2, kalau saya lukis macam ni, kita tak nampak the molecule. So O2 is one molecule. This is one molecule. There are millions and millions of molecules of O2 dalam satu gelas air. So what happens dalam satu gelas air ni, air yang dalam satu gelas ni, ada ikatan. There is an attractive forces. There is an attractive, sorry lah, my English. There is an attractive force that binds all of these molecules together. So what does that mean? This is known as intermolecular force. Intermolecular force. Perbezaan antara intermolecular force dan juga dengan intramolecular force, kita kena zoom. Okay, let me use a different thing. So if we take this, sorry, not this one. If we take a look at between these two, so you can see here, focus on these two, on these two molecule of oxygen. You have to understand, O2 itu adalah ikatan antara dua oxygen atom. This is O2. Okay, dia terikat dengan ikatan covalent dekat sini. So another O2 molecule tadi ada kat sini. Dia also terikat. This is a covalent bond. So macam saya cakap tadi, these two are, kita guna ink biru to describe intermolecular forces. So this molecule is bonded to that molecule by intermolecular force. Okay, this is one molecule. This is one molecule, and this is one O2 molecule. So both molecules are bonded, are attracted by intermolecular force. Ikatan ni kita kenali sebagai intermolecular force. Tetapi kalau kita cakap tentang intramolecular force, that means we are describing the force between these two atoms. So this covalent bond here, this is intramolecular. Okay, itu adalah perbezaan antara intermolecular force dan juga intramolecular force. Kalau inter, ikatan antara molekul. Kalau intra, dia adalah ikatan antara atom di dalam sesuatu molekul. Okay, so that is the difference. I think that's the best way I could describe it with this drawing. Right, so now let's move on. Wait a minute, I'm trying to change screen. Okay, so that is the difference between intermolecular force and juga intramolecular force. So the purpose of this, bukan the purpose, this intramolecular forces stabilizes between individual molecules. Sesuatu macam saya cerita tentang sorry O2 pula, H2O lah, astagfirullahalazim. Contoh saya bagi pun tak betul. but never mind, the logic is there. Okay, so intramolecular forces stabilizes between the atoms inside of a molecule. Okay, kalau kita cakap tentang intramolecular forces, we are talking about one molecule. Kalau we talk about intermolecular forces, we are talking about multiple molecules. Okay, both of them stabilizes the molecules and juga the atom. So kita boleh describe, kita boleh gambarkan some physical properties by understanding inter dan juga intramolecular forces. Contohnya boiling point. Okay, kalau kamu panaskan air, if you take a cup of water, kamu didihkan dia, dia akan bertukar jadi steam, jadi wap air. Basically jadi vapor. So what happens is, kamu dah apply force, iaitu haba, pada air tu, kamu dah vibrate the molecules between the molecules of water sampai dia punya ikatan tu pecah. So, bila ikatan molekul antara H2O tu pecah, dia tak boleh exist as water anymore. That's why dia change dia punya form, dia punya phase jadi steam, jadi vapor, jadi gas. It is now exist dalam bentuk wap air. Okay, so that is an example of how intermolecular forces stabilizes, menstabilkan sesuatu bahan. Water exists as water in room temperature. But once kamu didihkan dia, kamu panaskan dia, dia jadi tak stabil. Because now the molecules vibrate too fast because it has a lot of energy. Okay, haba adalah satu bentuk tenaga. So if you supply haba kepada sesuatu bahan, in my example adalah air. Kalau kamu panaskan air itu, that means you are supplying heat to the water. So once a substance dapat heat, which is a form of energy, dia akan bergerak. The molecules and the atoms of water akan vibrate, akan move. It will move faster. It will vibrate rigorously. Sampailah ikatan, the intermolecular forces terhapus, pecah. It cannot bind the molecules anymore. That's why bila kita didihkan air, dia akan jadi steam. That is the water changing a phase from liquid to gas, basically. Okay, it changes phase because dia punya intermolecular forces sudah terhapus. So generally dalam slide saya ni saya tulis, saya kata intermolecular forces are much weaker than intramolecular forces. Ikatan antara molekul adalah lebih lemah dibandingkan dengan ikatan antara atom. It usually requires much less energy to evaporate a liquid. Kalau kamu nak didihkan air, kamu perlukan tenaga yang rendah. 100 degrees Celsius, you can do it in your kitchen. Tapi kalau if you take a water, kamu nak asingkan the atoms of hydrogen, hydrogen dan juga dua oksigen tu, you will require a lot more energy. Okay, kamu tak boleh buat dalam kitchen. You need a specific tool, you need more energy untuk kamu buat electrolysis proses untuk asingkan the atoms of hydrogen and oxygen in water. Okay, so itu yang saya masukkan. Intermolecular forces are much weaker than intramolecular forces. So this is an example. It takes about 41 kilojoule of energy to vaporize 1 mole of water dekat boiling point 100 degrees Celsius. But kamu perlukan 930 kilojoule. So kilojoule is the unit of energy. So kat sini kalau kamu tak faham what is kilojoule, just understand the amount of the value of number here. 41 is a lot less than 930. So a lot more energy is required to break the OH bonds in 1 mole of water. Kalau kamu nak didihkan, kamu nak separate the separation between molecules of water, 41 kilojoule saja, sangat rendah. Tapi kalau kamu nak separate the atoms of water, 930 kilojoule. Okay, more than 9 times dia punya requirement, energy requirement. So the boiling points of substances often reflect the strength of intermolecular forces. So kita boleh secara kasarnya kita boleh predict the strength of intermolecular forces by looking at the boiling point. If you have two substances, kamu ada contohnya you have water and you have hexane. Okay, so kalau kamu nak tahu, if you want to find out which intermolecular forces is stronger, you boil both of them. Kamu didihkan air, kamu didihkan hexane. Tengok boiling point siapa yang lebih tinggi. So kalau boiling point air lebih tinggi 100 degrees Celsius, that means ikatan intermolecular force of water is stronger. Sebab lebih banyak haba diperlukan, lebih banyak tenaga diperlukan untuk kamu didihkan dia. Okay, so that's what the last sentence means. The boiling point often reflect the strength of intermolecular force. Anytime now. Okay, so these are so to discuss the properties of condensed matter, kita understand dulu the types of intermolecular forces. So dalam this chapter, kita akan discuss 4 types of intermolecular forces. Kita ada dipole-dipole, dipole ion, dispersion forces dan juga hydrogen bond. So all of these commonly refer as all 4 intermolecular forces ni is commonly known as the van der Waals forces. So let's take a look at the first one, iaitu dipole-dipole forces. So dipole-dipole forces are attractive forces between polar molecules, iaitu between molecule yang ada dipole moment. So what is dipole moment? It is basically, I think I have an idea. Saya nak lukis ni. Apa kata saya bawa dia ke sini? 1 minute lah, sorry. I need to change screen again. Okay, I'm sharing at this screen. Besarkan balik. Okay, so to understand dipole-dipole forces, first kamu kena faham apakah itu polar molecules. So untuk understand polar molecules, you have to understand dipole moment. Kamu belajar ni dalam chapter 3. So maybe dah terlupa. Okay. So untuk ingatkan balik, what is dipole moment? Let's say saya ambil contoh water H equals to B. We go back. Yeah, let's say we talk about water. Adakah air ini polar? So H2O is known as the universal solvent. It is known as a polar substance, polar solvent. So what is polar? So to understand what is polar, kita perlu faham apakah itu, whether it has dipole moment or not. So right now, saya nak explain apakah itu dipole moment. To understand, to identify whether one substance is polar or not, kita kena identify whether it has a dipole moment or not. So to describe, to identify water ni ada dipole moment ataupun tidak, it is best that you draw the structure, the Lewis structure ataupun the shape yang kamu belajar dalam chapter 3. So this is the shape of water. It is hydrogen bonded to oxygen and then another H2. Oh, my bad. Sorry. Saya pun dah pening. Oxygen ada 2 lone pair kat atas. Bonded with a hydrogen, bonded with a hydrogen. So here we can see untuk determine whether sesuatu molekul itu polar ataupun tidak, ada 2 syarat yang kita perlu patuhi. Syarat yang pertama, dia mesti oh no, what's the first one? Not symmetrical. What is the second one? I forgot the word. Ada dalam lecture note, tapi saya tak ingat. But basically, kamu kena tengok whether it has a dipole moment or not. So untuk determine whether this molecule, water molecule, ada dipole moment or not, kamu kena faham electronegativity. So electronegativity is basically a force ability of an atom to attract electrons. Itu electronegativity. Okay. So dalam this molecule of water kita ada dua atom, oxygen dan juga hydrogen. So oxygen is more electronegative than hydrogen. Kita boleh tentukan ini by looking at the periodic table. The element on the right side of the periodic table, electronegativity dia lebih tinggi. Hydrogen dalam grup pertama, paling kiri sekali. Grup yang paling kiri sekali. Oxygen dalam grup 16. It's farther to the right. So therefore, oxygen is more electronegative. So what does that mean adalah, oxygen dalam molekul air ni, dia ada kebolehan untuk tarik elektron ke arah dia dengan lebih banyak. So basically, dia akan attract the electrons in hydrogen. So what happens here, dia akan tarik electron, go towards itself. So there's a movement of electron, there's a traffic of movement of electron from hydrogen towards oxygen. And this will result in a dipole moment, which is a movement of electron ke arah atas. So this is what we call as a dipole moment. Delta negative meaning dekat belah oksigen ni ada lebih banyak elektron. This is delta positive because less electrons are found around hydrogen because oxygen tarik most of the electron ke arah diri sendiri. So once a molecule ada dipole moment, once dia ada dipole moment and dia tidak symmetrical, so this substance is polar. So this molecule of water adalah polar. Dalam chapter 3 kita bandingkan H2O dengan carbon dioxide, CO2. So CO2 the structure is like this. Once you have drawn the Lewis structure, bentuk dia macam ni. So oxygen is more electronegative than carbon. So dia akan tarik electron of carbon towards itself, iaitu oxygen. Saya nak change color pun. So bila dia tarik electron towards itself, tak cerah langsung. Sorry, too bright. So electron tarik ke arah oxygen. So there's a movement of electron from carbon towards oxygen. But the problem is, walaupun dia ada dipole, okay, ikatan, the bond is polar, I remember. Bond is polar. Polar terbalik. Okay, so kat sini untuk CO2, the bond is polar. Okay, ada dipole moment kat sini. From carbon ada pergerakan ke arah oxygen. So delta negatif kat sini, ini delta positif. There's a movement of electron dari carbon kepada oxygen. But because the shape is symmetrical. Symmetrical meaning if you draw a mirror in the middle, if you draw a line in the middle, the left hand side is, the punya shape is similar to the right. So untuk carbon dioxide sama. So because of this, the force, the dipole moment here is equal. Yang belah kiri dengan belah kanan sama. So ultimately, this results in a no movement at all, no dipole moment. Because saya bagi perbandingan macam tarik tali. Kalau kamu ada satu game tarik tali, team A dan team B sama kuat. And dua-dua tarik at the same time, theoretically tak ada pergerakan. Because dua-dua team sama kuat. There's no movement. Okay, tarikan team A sama dengan tarikan team B. So tak ada pergerakan lah because dua-dua sama kuat. So the same logic applies here, meaning the movement on the right side cancels out the movement on the left. So therefore there's no dipole moment. So kalau tidak ada dipole moment, CO2 jadi non-polar, dia tidak polar. So this is how we determine whether sesuatu molekul itu polar ataupun tidak. The first syarat is bond mesti polar. The second syarat is the shape must not be symmetrical. So, kita tengah cakap tentang apa nama polarity tadi kan? Mana saya punya slide? So dipole forces ni kita cakap we are talking about an attractive force between polar molecules. So dalam gambar rajah ni, dalam this diagram yang saya share ni, it basically shows the how it works. Sekejap, saya tunggu dia nak load. Lambat pula. So kamu tengok kat sini, this is a molecule. Yang ada positive negative ni, it shows the dipole moment lah. Okay, so positive is the positive end of the dipole. Negative is the negative end, meaning electron are concentrated around the negative area. So kalau kita cakap tentang dipole forces, meaning the ikatan antara the negative end and the positive end. Apa contoh yang macam ni? Saya tengah nak fikir satu contoh example dipole in polar molecules. Tidak, saya tak bagi example. H2O saya guna untuk hydrogen bond nanti. So once you katakanlah any substance yang kamu dah identify dia ada a dipole moment, meaning kalau macam contohnya macam air tadi. Okay, air H2O. Saya guna water je lah, senang. Mana dia? That's my drawing just now. So if you have water right here, kita dah establish tadi dia ada satu dipole moment kan. So H, O and H. So ini delta negatif, ini delta positif. Ini pun delta positif. So another molecule will be here, delta negative here. Another hydrogen, ini pun delta positif, delta negative. So ada 3 molecules of water here. So dalam gambar aja dalam lecture note tadi tu, dalam slide tadi tu, dia tunjuk macam ni saja kan. Just an oval shape, positive and negative. Just an oval shape of positive and negative. So what does that mean adalah these are molecules lah. Molecules and dia punya dipole, positive and negative. So ikatan antara these molecules is by dia punya different, saya guna a different color. Different kutub yang different charges ni. Sama macam magnet, just think of a magnet. Kalau ada punya different kutub, magnet of different ends, dia akan attract one another. So kalau kita ada different pole here, negative and positive, dia akan attracted. Ini pun dia akan attracted. So we have, this is known as, ikatan ni is known as dipole. Dipole force. Itu sahaja. Okay, itu yang dimaksudkan dalam slide tadi. Negatif dan positif, tertarik antara satu sama lain. So that is dipole forces. Negatif dan positif, tertarik antara satu sama lain. So that is dipole forces. So that's why kamu belajar dalam chapter 3 dulu. Apakah itu polar, non-polar solvent, non-polar molecules. How do you macam mana nak figure out whether that molecule is polar ke atau non-polar, dia ada dipole moment ataupun tidak. So this is the application. Kat sini kamu guna pakai that knowledge. Next is ion dipole forces. So kat sini adalah ikatan antara ion dan juga dipole. So specifically kalau kamu nak faham ni, kamu kena faham what is ion first. So kalau kamu terlupa, ion adalah just an atom yang ada electric charge, yang ada kutub charge ataupun positif. So dalam my lecture note tu saya bagi contoh Na plus dan juga magnesium 2 plus. So dia ada positive charge kat sini, 1 plus dan juga 2 plus. So kalau kamu ada a dipole, katakanlah molecule of water, hydrogen dan juga hydrogen. So this is delta negatif, ini delta positif, delta positif. Sama juga kat sini. Delta negatif, ini delta, ini delta positif, ini delta positif. Delta means there's a change in electrical, in movement of electron. Okay, so kalau sini adalah bercharge negatif, sini bercharge positif, so adalah ikatan antara dua ni, boleh terhasil ikatan. So this is how sesuatu garam boleh larut dalam air. We have magnesium salt boleh larut dalam air because dia boleh hasilkan ikatan. Sodium salt boleh larut dalam air because dia boleh form ion dipole forces. So ikatan antara ion, this is ion, and A plus is ion. Bila sesuatu atom dia ada charge, that is an ion. So Na plus, this is your ion. This is your dipole. Dia bukan dipole. This is the dipole, not the whole thing. Okay, dipole negatif. Ini dipole positif. So terhasil ikatan. Ini pun sama. Magnesium 2 plus is the ion. Ini adalah dipole. So this is known as the ion dipole force. Where's my mouse? Okay, next kita habis ni with lagi 10 minutes and 9 minutes. Please bear with me. After ion dipole forces, we have, please move next slide. Anytime now. So kat sini saya tulis the charges on cations are generally more concentrated. Because cations are usually smaller than anions, and therefore the cation interacts more strongly with the dipole than does an anion having charge of the same magnitude. So kat sini saya nak kamu maybe a refresher juga at what is an ion, what is cation. So cation adalah satu term yang kita guna untuk describe ion yang bercharge positif. So tadi saya lukis Na plus dan juga Mg2 plus. So bercharge positif itu adalah cation. That's the term. Kalau anion, we are talking about negatively charged ion. So kat sini saya kata the charges on cations are generally more concentrated because cations are smaller than anion. So kita cakap tentang size. Okay, so kalau size ion tu lebih kecil, dia boleh hasilkan ikatan yang lebih kuat. Okay, so just think of macam inilah, kalau kamu ada kawan kamu tu kecil, so lebih mudah untuk kamu pegang dia. Kalau dia lari, you are stronger than your friend. You can hold him in your arms. Kamu perlukan tenaga yang sikit saja untuk pegang dia, to bound that person. If your friend is bigger than you, so you will need a stronger force to hold that person. So ikatan kamu akan jadi lebih lemah because kamu are smaller than that person. So think of this is the peranan of size, the effect of size on the interaction between the ion dan juga the dipole. So antara Na, because Na size lebih besar, ikatan the ion dipole force is weaker than magnesium. Magnesium size lebih kecil. Itu yang dia kata dekat sini. Next is dispersion forces. Dispersion force kita describe ikatan dalam non-polar molecules. So dalam the previous two, ion dipole dan juga dipole-dipole, kita cakap tentang polar molecules. Okay, both all the molecules ada dipole moment. Tapi kalau dispersion forces, kita cakap tentang ikatan dalam non-polar molecules. Contohnya macam carbon dioxide gas, non-polar substance. Hexane, non-polar. Okay, so dispersion forces is the main ikatan dalam non-polar forces. Dispersion forces adalah attractive forces that arise as a result of temporary dipoles induced in atoms of molecules. This is also known as London forces, usually increase with molar mass. Lagi besar sesuatu molekul tu, lagi kuat ikatan dispersion force ni. Because molecule with larger molar mass tend to have more electrons. So dispersion force ni increase kalau ada lebih banyak electron. And lastly adalah hydrogen bond. So hydrogen bond is specific. Okay, this is the strongest force between all four. Hydrogen bond is a special type of dipole-dipole interaction. Dia adalah sejenis dipole-dipole interaction, tapi dia specific to some molecules sahaja. So this is because it only exists between hydrogen atom and between electronegative atoms. So ikatan antara any molecules yang ada macam contohnya NH, nitrogen, hydrogen, oxygen, hydrogen ataupun fluorine, hydrogen. So nitrogen is very electronegative. Oxygen is also very electronegative. Fluorine is also very electronegative. So any molecules that has all these atoms and other hydrogen, the hydrogen bond is the main attractive force. So contoh yang saya dah lukis tadi dalam air. Mana whiteboard saya? So dalam contoh air tadi, let's go back. So this mana saya punya okay dah color ni. So kita boleh tengok kat sini dipole-dipole moment, dipole-dipole antara positif dan negatif. So ada ikatan antara oxygen, which is an electronegative atom, dengan hydrogen. Kat sini pun sama, ada ikatan antara this and this, ada this and this. Katakanlah ada lagi kat atas pun ada ikatan. So this ikatan, this is known as hydrogen bond, H bond, orang selalu tulis, which is a type of dipole force, tapi spesifik between hydrogen dan juga electronegative force. Kalau kita ada, saya bagi contoh lain, ammonia for example. NH3. So sini negatif, dan ni semua positif. Kalau ada lagi ammonia kat sini, ammonia molecules is NH3. So sini negatif, sini positif, and positif. Ada ammonia negatif, hydrogen, and hydrogen. So dia boleh form a hydrogen bond between this negative and positive. And so sini positive and negative terhasil ikatan. So this is a hydrogen bond. Ini pun sama. This is how this molecule, this substance exists. So this is known as hydrogen bond. HCl pun sama, hydrogen and chlorine. So this is the negative, this is the positive. HCl, negative, positive. HCl, negative, positive. HCl, negative, positive. So kalau ada ikatan, the hydrogen bond is between this two so ikatan tu sangat kuat because multiple N boleh terhasil. Because of it, chlorine is very electronegative and dia ada banyak ikatan boleh terhasil. Sini pun boleh. So it's like macam kalau kamu ada apa nama banyak tali, okay, kamu tak kemas, kamu ada wire dekat rumah kamu ada banyak, and dia macam berselirat antara satu sama lain. Kalau kamu nak tear it apart sangat susah because dia dah terikat dengan many different ways, dah berselirat antara satu sama lain, dia dah bersimpul-simpul. So that's why wire kat rumah tu, kalau kamu ada komputer ke TV ke anywhere in your home, kamu ada wire yang berselirat yang banyak-banyak. That is basically what a hydrogen bond is like. Banyak cara dia boleh bond itself. The atoms in the molecules boleh terikat dengan many variations, many combinations. Sini pun boleh. So that's why dia punya ikatan tu dah sangat banyak dan berselirat sangat-sangat. That's why hydrogen bond is a very strong bond, saya kata tadi, between all these four forces. Okay, so I think that's it untuk the intermolecular forces. Tapi ada lagi, kita akan sambung. So kita sambung, we take 30-minute break and then kita sambung after that. Okay?
Okay,
See
sir.
you at 11, huh?
All right.
Thank you
Okay,
all.
sir.
Assalamualaikum, good morning. Hopefully everybody dah all rested. Dah beli lunch dah? Ada yang dekat hostel dah ready dengan lunch ya? Saya berharap kita akan habis ni by pukul 12, 1 jam saja lagi. Kita nak habiskan the rest of the chapter sahaja. Kenapa dia duduk kat sini? Oh sorry, wrong ni. Okay, kita dah halfway through. Hopefully in 1 hour kita boleh habiskan. Probably less in 1 hour. Semua boleh dengar saya? Kalau tak dengar, tolong beritahu. Okay, so kita dah go through all 4 of the intermolecular forces, iaitu dipole-dipole force, ion dipole force, dispersion force ataupun London forces, and lastly hydrogen bonds. So tadi kita tengoklah hydrogen bond, dia adalah basically it's a dipole-dipole force, tapi specific to hydrogen and electronegative ions, atoms sahaja. So these are the examples. Tadi saya ada lukis. These are some of the examples of hydrogen bonds. This is between hydrogen bond between water, hydrogen bond between ammonia and H3, hydrogen bonds between water and ammonia. This is ammonia and water. This is hydrofluoric acid and ammonia. This is ammonia and hydrofluoric acid. Okay, so the strength of a hydrogen bond kat sini saya tulis is determined by the Coulombic interaction between lone pair electrons of the electronegative atoms and the hydrogen nucleus. Basically kat sini what it means is kekuatan sesuatu hydrogen bond itu bergantung kepada the amount of lone pair electron. So lebih banyak lone pair electron sesuatu hydrogen bond tu ada, kan, sesuatu molekul tu ada, lebih kuatlah hydrogen bond. So for example here H2O, dia ada 2, oksigen kat sini ada 2 lone pair. Lone pair meaning the 2 electrons. Ini satu pasang elektron, ini satu pasang elektron. Hydrogen, water ada 2 lone pair. Dua-dua atas oksigen. Ammonia ada 1. So kalau kita nak compare the strength of the hydrogen bond between water and water dan juga ammonia dan ammonia, the hydrogen bond in water molecules are stronger compared to ammonia because the amount of lone pair is more. Right? So once we have understood these intermolecular forces, barulah kita boleh explain, kita boleh describe the properties of liquids. So that's why kat sini saya tulis intermolecular forces give rise to a number of structural features and properties of liquids. Struktur sesuatu liquid tu dan dia punya sifat-sifat dia bergantung kepada intermolecular force. Macam tadi saya cerita tentang takat didih. Kita boleh predict the strength of dipole-dipole force based on the takat didih sesuatu bahan tersebut. Tadi saya bagi contoh, kalau kita ada 2 liquid, iaitu air dan juga hexane. So kalau saya nak tahu ikatan intermolekular mana yang lebih kuat, kita didihkan kedua-dua, air dan juga hexane. So kalau takat didih mana yang lebih tinggi tu, that means ikatan dia lebih tinggi. The intermolecular force is stronger. Itu maksud intermolecular forces here give rise to a number of structural features and properties of liquids. So takat didih itu adalah ciri lah liquid. So in this section, in the properties of liquids, we will look at 2 such phenomena associated with liquids in general, iaitu surface tension dan juga viscosity. Kita nak discuss 2 ciri cecair kat sini. Then we will discuss the structure and properties of water. So what is surface tension? Molecules at the surface, molecules of liquid. Okay, molecules of liquid pada permukaannya are pulled downward and sideways by other molecules, but not upward away from the surface. So tengok figure 11.8. So kat sini saya attach figure 11.8. It's basically kalau kamu ada satu beaker dipenuhi dengan air, dia tunjuklah tarikan, arah tarikan intermolecular force. So kat sini kita tengok, kalau kat ke tengah-tengah ni, molekul di tengah-tengah ni, daya tarikan tu is in every direction, atas, bawah, kiri, kanan. Tetapi pada permukaan liquid, pada permukaan cecair tu, tidak ada molekul dekat atas dia. So tidak ada daya tarikan ke atas. So basically what happens is, daya tarikan pada permukaan cecair tu only limited kepada bahagian tepi dia dan bahagian bawah sahaja. So these intermolecular attractions pada permukaan liquid ni, dia akan menghasilkan satu ciri yang mana cecair tu dia macam tertarik, macam satu lapisan plastik yang ditarik. So this is what we call surface tension. So what happens is surface tension, because there is little or no attraction between polar water molecules and say the non-polar wax molecules of a freshly waxed car, a drop of water assumes the shape of a round bead, macam butiran. Kalau kamu tengok, kalau kamu keluar rumah pagi-pagi, there's a dew, ada embun pagi. So how it forms the shape of the embun, of the dew, is because of surface tension. Okay, pada permukaan liquid tu, pada permukaan embun tu, di permukaan luar sekali, dia tidak ada daya tarikan di bahagian atas. So basically, pada permukaan liquid tu dia ditarik to the sides and pada bahagian to the downward of the direction of the molecule of the dew. So that's why dia boleh menghasilkan satu bentuk macam bead, macam butiran, sebutir embun. So this is an example of surface tension. Another example is pada permukaan air, certain species of bugs dia boleh berjalan atas air. So surface tension pada gambar rajah ni enables the water strider to walk on water. Because pada permukaan air tu, because there is no intermolecular forces di bahagian atas dia, dia basically dia ditarik, dia jadi macam elastik, macam filem yang elastik. So kalaulah berat jisim water strider ni tidak terlalu besar, it basically boleh thread, dia boleh stretch the molecules of the water pada permukaan tu so that it can stand on water. Next adalah viscosity. So the second property yang kita nak discuss dengan lebih lanjut adalah viscosity. Viscosity is the measure of a fluid's resistance to flow. So the greater, lebih tinggi viscosity sesuatu cecair itu, the slowly the liquid flows. Okay, viscosity adalah kebolehan sesuatu cecair untuk melawan arus. So the viscosity saya tulis kat sini of a liquid usually decreases as temperature increases. There's a table here, 11.3. It describes the viscosity of some liquids at 20 degrees Celsius. You can see here acetone, benzene, blood, carbon tetrachloride sampailah water. So water here kat sini, liquids that have strong intermolecular forces have higher viscosities than those that have weak intermolecular forces. So higher in this case adalah water. 1.01 darab 10 kuasa negatif 3. So kalau kamu, because saya pernah tunjuk table ni to my previous class, dia tanya saya kenapa water is bacaan dia higher, sedangkan nombor dia 1.01. Acetone is lower than water, 3.16. So don't forget about the scientific notation. Kalau acetone 3.16 darab 10 kuasa negatif 4. So dalam table tadi, acetone dia punya bacaan adalah 3.16 darab 10 kuasa negatif 4. Kalau water, it's berapa tadi? 1.01 darab 10 kuasa negatif 3. So this is the measurement of viscosity. So don't forget about this. Dia punya apa nama? Scientific notation. Hey, susah betul. So basically what it means here, kalau kita expand this, dia akan jadi 0.00123. 0.316. 1, 2, 3, 4. So kalau kat sini pula, 0.00101. So kat sini nombor ni is bigger. 0.00101 is bigger than 0.00316. Sini ada 1, 2, 3, 4, 5. Ada 4 titik perpuluhan baru ada 1 digit integer. Kat sini 3 saja. 3.1, 2, 3. So water has the bigger value untuk viscosity. So that's why this is bigger. So tengok balik table tadi. That's why water has the highest viscosity in this table. And not true. Except for glycerol. So kat sini kita nak discuss. Kenapa glycerol? Kenapa glycerol has the higher viscosity here? Water has high viscosity than any other liquids because of its ability to form hydrogen bond. Kebolehan air tu untuk menghasilkan ikatan hidrogen antara molekul-molekul air yang lain menyebabkan dia mempunyai bacaan viscosity yang tinggi. Very viscous, sangat mudah mengalir. So interestingly, the viscosity of glycerol is significantly higher than all of the other liquids. Okay, viscous meaning pekat. So water is more pekat than acetone, benzene, apa lagi? Carbon tetrachloride, diethyl ether, darah lebih pekat daripada air. Tapi glycerol kat sini 1.49, sangat tinggi. So sangat pekat. So why is that? So this is the structure, the molecular structure of glycerol. CH2OH bonded to another CHOH and CH2OH. So like water, glycerol can form hydrogen bonds. So each glycerol molecule has 3 OH groups. There are banyak OH groups. So this means there ada banyak atom yang elektronegatif dan dia ada banyak lone pair. Setiap O dalam glycerol tu ada 2 lone pair. So dia ada 3 oksigen. So that means dia ada 6 lone pair. So imagine the hydrogen bonds, the amount of hydrogen bonds yang dia boleh hasilkan, amount hydrogen bonds yang kuat dia boleh hasilkan that can participate. So that's why glycerol has very high viscosity. That's why dia sangat pekat. So kita boleh describe the viscosity of sesuatu liquid tu, of a liquid, by describing the intermolecular force. So in this case, kita boleh guna hydrogen bond untuk jelaskan kenapa glycerol sangat pekat. Okay, so because of the shape also, the molecules have a great tendency to become entangled. That's why saya bagi contoh macam wire yang berselerak dekat rumah. So if you have, kalau macam ada desktop PC kat rumah, kamu ada home TV dengan speaker kat rumah, mesti ada wire banyak bersimpul-simpul dekat belakang tu. So because of the shape, sama macam glycerol tadi, it has a great tendency to become entangled. That's the word, the key word here. Entangled rather than to slip past one another, as the molecule is less viscous liquids do. So these interactions contribute to high viscosity. So on the right side ada satu like depiction lah of the 3D molecular structure of glycerol. So it is a clear liquid, odorless, tak ada bau. Dia macam sirap, dia punya kepekatan tu menyebabkan dia nampak macam sirap. It is used to make explosives, kita buat ink dan juga lubricant. Okay, now kita nak tengok solutions pula. So solution is a homogeneous mixture of 2 or more substances. You have to make the distinction. Kamu kena bezakan antara solution dan juga liquid. Do any of you know what is the difference? Apakah beza antara liquid dan solution? Ada sesiapa nak hantam, nak mencuba nasib? What is liquid? What is solution? Dalam bahasa Melayu,
liquid tu tiada campur, solution tu campuran antara 2 atau banyak-banyak.
Thank you, sebetul. Is that you, Chuan?
Yeah, sir.
Okay, thank you. So that is the right answer. So liquid tak bercampur, solution tak bercampur. Cecair meaning it is only one substance. One substance. Kalau larutan, solution, it is a mixture. Okay, so what does that mean adalah if you have a glass of water, pure water, so dalam glass tu only has H2O. H2O. So this is cecair. But kalau saya masukkan a spoonful of sugar, satu sudu, 1 tablespoon of sugar into this glass of water. Now, I have turned this liquid into larutan. A solution, a sugar solution. Now, inside this water, it is also mixed with glucose. Glucose. So H2O has formed some sort of intermolecular force with glucose. Dah ada ikatan antara H2O dan glucose molecules. So that is the difference between cecair dan juga larutan, liquid and solution. Alright, so that means untuk kita hasilkan sesuatu solution, you are going to need three things. You're going to need two things. You need something to go into something. Okay, you need a solute and also you need a solvent. Solute is the stuff that is going to be dissolved. Solvent is the stuff that is dissolving. Okay, solute going to be dissolved. Solvent is dissolving it. So what happens when you mix the two? Kamu akan dapat solution. So dalam example saya tadi, kalau kamu ada, this is sugar. This is a 1 tablespoon of sugar. This is sugar. Penuh satu sudu. And you put this sugar into a cup of water. This is H2O. So this is solute. This is going to be dissolved. The sugar will be dissolved inside this glass of water. So this is your solvent. So when you mix the two, kamu akan dapat a sugar solution. Sugar solution. So these are the three things yang kamu kena faham when you talk about solution. You have solute, solvent, and when you mix the two, you get a solution. So when we talk about solution, a solution is a homogeneous mixture of two or more substances. Maksudnya dia larut dengan sebati. Contohnya macam air gula tadi, air garam, ataupun air Milo, air teh, kopi. Those are examples of solutions. Tetapi dia tidak limited. It is not only limited to liquid only. Okay, it can go as far as gas and also solid. Janji it is a mixture solution. So kalau kamu ada udara, the air that we breathe, macam kita dah establish in the last chapter, the air that we breathe are not only does not only contain oxygen saja. It contains all other gases also. So nitrogen, carbon dioxide, all the other noble gases. Neon and argon and so forth. So that is also considered as solution. So chemists consider those things as solution also. So a solution may be gases, saya tulis kat sini, such as air. Solid, such as alloy. Alloy is a mixture of different metals. Ataupun liquid, contohnya macam air laut, air sungai, air gula, air garam, air kopi, air ori kamu bancur kat rumah. That is a type of solution. So do not limit your understanding of solution ni kepada liquid semata-mata, because as a pharmacist you have to understand when you formulate drugs, you are not only dealing with ubat liquid. You make suspensions, you make tablets, you make capsules. So you have to understand some ubat macam nebulizer, is also gas, dalam bentuk gas. So medications, pharmaceutical drugs exist in different types of phase. So as a pharmacy student, you must have a good understanding kalau kamu nak describe the properties of certain drugs, kalau kamu nak formulate certain drugs, you nak prepare, you nak handle certain drugs, you have to understand how it behaves, the properties. So types of solutions kat sini, kita boleh describe bila kita dah faham all these intermolecular forces, kita boleh describe solutions in different types. So our focus in this chapter will be on solutions involving at least one liquid component. Maksudnya gas yang larut dalam liquid, ataupun liquid yang larut dalam liquid, ataupun solid yang larut dalam liquid. So these are different types of solutions yang mana dia punya composition of substance tu is between these three things. Gas dalam liquid, liquid dalam liquid, solid dalam liquid. So chemists, macam saya cakap tadi, also characterize solutions by the capacity to dissolve a solid. Kita gambarkan larutan tu dari segi kebolehan dia untuk melarutkan bahan. So a saturated solution, kita categorize solution dari segi kebolehan dia untuk larutkan bahan. So ada 3 jenis kat sini, saya dah bold the types. Kita ada saturated solution, unsaturated solution dan juga supersaturated solution. So untuk saturated solution meaning sesuatu larutan tu it contains the maximum amount of solute that will dissolve in a given solvent. Tak boleh boh lagi dah. If you add more solute bahan tu tak akan larut. Selalu saya bagi example dalam kelas, kalau kamu bancuh air Milo. Okay, let's say kamu ambil satu gelas air panas, kamu letak 10 sudu serbuk Milo. That's a lot kan? We can all agree 10 sudu serbuk Milo dalam satu air panas, that's a lot of serbuk Milo. So once you stir the air Milo, the solution, kamu akan dapat air Milo. But after a while, kamu dah stop kacau, you let it stand on the counter for a while, kamu akan perasan at the surface of the air Milo, dia akan timbul this dark brown crystals, blotches. Okay, itu adalah serbuk Milo yang tak boleh larut because dah tersangat tepu. So bila kita cakap tentang saturated solution, kita cakap pasal ketepuan dia lah. Saturated meaning it contains the maximum amount of solute. Okay, dia tak boleh add lagi, it cannot dissolve any more solute. So the difference between saturated dengan unsaturated meaning the solution contains less solute than it can dissolve. And lastly, the third type is supersaturated solution, meaning the solution contains more solute than it could have dissolved. Okay, this is given kalau kita supply an external force macam high temperature ataupun high pressure. Let's say air Milo dengan 10 sudu serbuk Milo tadi tu tak larut kan, kita dah kacau banyak kali pun dia akan timbul balik. So let's say you take that glass of air Milo yang sangat-sangat yang dah terlebih tepu tu, kamu masukkan dalam microwave. So bila dah masuk dalam microwave, you turn it on, panaskan dia for 1 minute. So once you've taken it out, kamu akan dapati serbuk Milo yang timbul tadi tu semua akan hilang sebab dia dilarutkan dengan bantuan temperature yang lebih tinggi. So itu maksud supersaturated solution. A solution that contains more solute than it could have by the help of an external force. External force here dalam contoh saya itu adalah temperature yang lebih tinggi ataupun tekanan yang lebih tinggi. So supersaturated solution ni are not very stable. So once tadi air Milo yang dah dikeluarkan dari microwave itu semua dah larut kan. So once you have once it has cooled down, dah letak balik atas meja, dia dah sejuk balik, dia akan timbul balik semula. So itu yang dimaksudkan supersaturated solutions are not very stable. Dia akan hilang dia punya kebolehan tu. Another example is air gas. Kalau kamu beli air gas, air tin, kamu buka tin tu, kamu akan dengar bunyi psh. That is carbon dioxide escaping the solution. Okay, bila kita buat air gas, basically kita akan jam, kita akan compress carbon dioxide, gas carbon dioxide dalam larutan tu. So bila kita dah buka air gas, tin air gas tu, carbon dioxide akan dibebaskan. So after a while, tekanan dah makin berkurangan. So once you have left the tin tadi tu, air tin tadi tu atas counter, let's say for 30 minutes, kamu akan rasa air gas tu, dia punya gas dah makin kurang. Dah tak kuat dah. Minum pun dah tak sakit tekak dah. So that is because carbon dioxide has escaped, more carbon dioxide inside the solution has escaped into the surrounding air. Itu adalah contoh super saturated solution tidak stabil. So in time, some of the solid will come out of a super saturated solution as crystal. Ini contoh macam air Milo dengan 10 sudu serbuk Milo tadi tu. Tadi saya kata after a while, kalau kamu biarkan dia akan timbul dekat atas kan. So kita panggil proses tu sebagai crystallization. Oops. So bila kita dah faham the different types of solutions, we can talk about solubility, kebolehan of solvent untuk melarutkan solute. So this is a measure. Solubility is a measure how much solute will dissolve in a solvent at a specific temperature. Typo dekat situ. So the saying like dissolves like is helpful in predicting the solubility of a substance in a given solvent. So apakah yang dimaksud dengan like dissolve like ni is it means that the two substances with intermolecular forces of similar type and magnitude are likely to be soluble in each other. Two liquids are said to be miscible if they are completely soluble in each other in all proportions. So contohnya macam methanol, ethanol dan ethylene glycol are miscible with water because they can form hydrogen bond. Kalau kamu ada satu cecair methanol, kamu campurkan dalam satu gelas air in a beaker of water. So when you kacau, tak perlu kacau pun, it is instantly soluble. You will not see a difference. So itu maksud miscible. So it is a solution is miscible kalaulah both composition, contohnya macam methanol dan air itu mempunyai intermolecular forces yang lebih kurang sama. So dia boleh hasilkan lebih banyak intermolecular force, lalu dia larut dengan mudah. Okay, contoh other example kalau macam solid, gula dan garam. So dia punya intermolecular force is similar. Gula similar dengan air. So that's why dia sangat mudah larut. Garam lagi mudah larut. Okay, because of the size it is smaller and also dia punya similarity of intermolecular force, dia boleh form ion dipole force between the salt and the water. So dipole-dipole force boleh terhasil, larutlah dengan mudah. So this is a molecular view of the solution process. Kita ada solute, solvent, and then solution. So there are 3 steps here. So what happens bila a solute is dissolved in a solvent? Dalam gambar rajah ni dia akan describe what happens. So kalau in the beginning kamu ada solute. So you take a spoonful of that solute, you put it in a solvent. So what is happening bila when they two interact with one another, basically dia akan setiap bahan ni solute dia akan expand dulu, dia akan break apart. So this is what it is described here. Solute with the help of energy, heat, dia akan break apart. Dia akan pecah. Solvent is also the same. Dia akan break apart juga. Okay, so it depends on whether dia akan menghasilkan haba ataupun dia akan terima haba. So when it has break apart, dia akan hasilkan ikatan, intermolecular force between the solvent and the solute. So bila dah terhasil ikatan, dia akan menghasilkan solution. So kat sini saya tulis, step 1 is the separation of solvent molecules and step 2 entails the separation of solute molecules. So kita start dengan solvent. Solvent tu yang akan melarutkan. So it breaks apart first and then solute will break apart and then it will combine. So these steps require energy input to break attractive intermolecular force. Untuk pecahkan ikatan intermolecular force ni, dia perlukan tenaga. Itulah yang dimaksudkan dengan segitiga H1 ni. Segitiga H2. Kita perlukan tenaga. Most of the time dia adalah haba lah. Okay, tapi sometimes it could be pressure also. So therefore they are endothermic. Kalau kamu tak ingat apakah itu endothermic, it means energy disrupt. Kita supply energy into the process. Enter. That's how I remember it masa saya student dulu. EN tu basically it means enter. So the energy goes into the process. And then in the end, oops. Oh, kenapa dia go back? Okay, so the heat solution is given by this. This is the formula untuk kita describe. The energy required to produce a solution can be described using this equation. The heat of the solution equals to heat 1, which is the solvent punya heat, and then heat 2 is the solute, and then heat 3, which is this one, when both of them mix together. So this is the molecular view of the solution process portrayed as taking place in 3 steps. If the solute-solvent attraction is stronger than the solvent-solvent attraction and the solute-solute attraction, then the solution process is exothermic. Kat sini, once we have performed the calculation, okay, solute-solvent attraction meaning here lah, solute-solvent attraction, step 3. Ikatan antara solute dan juga solvent. So dia kata kat sini, kalau ikatan ni, dia punya enthalpy delta H3 ni lebih tinggi daripada delta H1 dan delta H2. So the process will be exothermic, meaning dia akan menghasilkan haba. Exo meaning the energy will go out, exit, EX. So kalau kamu mix solution A and solute B, and then you mix them together, kalau kamu pegang the beaker of the solution, kamu akan rasa panas. So that means the solution is exothermic. Dia akan exude, dia akan keluarkan haba. So kalau kamu perform the calculation, bacaan of the heat solution will be less than 0. So vice versa, if the heat of solution is bigger than 0, and that means the process is endothermic. So that means dia akan serap haba. Solution tu akan rasa sejuk. Alright, and last topic ia adalah colligative properties. So colligative properties ni is very, apa saya nak kata, is very layered, very complex. So dalam this our syllabus, saya just nak kamu aware, kamu tahu what is colligative properties. Kamu boleh senaraikan at least. So kat sini saya tulis colligative properties ataupun collective properties are properties that depend only on the number of solute particles in solution and not on the nature of the solute particles. Dia bergantung kepada bilangan solute tu, tak bergantung kepada species dia tu adalah sejenis amin ke, sejenis alkohol ke, sejenis acid ke, base ke. Kita tak consider yang itu langsung. Okay, so dia adalah ciri-ciri sifat-sifat yang only bergantung kepada bilangan solute sahaja. So these properties are bound together by common origin, iaitu they all depend on the number of solute particles present, regardless whether they are atoms ke, ion ke, molecule. So these 4 adalah vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Kita boleh, saya tak nak go dengan lebih dalam daripada ni. Okay, because it can be confusing, it can be overwhelming. So basically for our syllabus, our level right now, saya nak kamu tahu, these are the 4 colligative properties. Because nanti dalam, kalau kamu sambung dalam degree, kamu akan boleh go dengan lebih kompleks lagi. Ada mathematical equation that you need to understand, ada banyak lagi theory yang kamu perlu add on so that you can discuss and understand this subtopic dengan lebih lanjut lagi. Okay, but for now remember colligative properties ada 4. Kebolehan untuk merendahkan tekanan vapor, tekanan wap. Kebolehan untuk meninggikan takat didih. Kebolehan untuk merendahkan takat beku dan juga tekanan osmosis. So these are the four properties, ciri-ciri yang tidak bergantung kepada dia adalah sejenis ion ke, atom ke, acid ke, base ke, alkohol or anything. Dia hanya bergantung kepada bilangan solid yang ada di dalam sesuatu larutan tersebut. Okay, that's it. Thank you. So kalau kamu rasa macam laju sangat, I apologize. Kita nak ganti kelas. Kalau kamu nak study balik, if you want to revise this chapter balik, go back to the beginning of the lecture note. These are basically the 4 things yang kamu boleh buat by the end. Okay, explain the properties of liquids, the viscosity and apa lagi satu tadi, surface tension, identify the different types of solutions, explain the process of solution and solubility. That means to do all this, kamu kena fahamlah the intermolecular forces. What are the 4 intermolecular forces? How are they bonded to each other? How are they attracted to each other? Get that down first. Maksudnya fahamkan bahagian ini betul-betul dulu. Barulah kamu boleh cerita dengan panjang-panjang lagi bahagian-bahagian yang lain. The properties of liquid. Because the properties of liquid and the types of solutions depends on you understanding the intermolecular forces. Okay, any question so far tentang ni?
Tiada,
Alright, so
sir.
kalau tak ada, tadi Chuan ada tanya saya, ada another assignment, group assignment, which is true, ada. I think this is the last group assignment. Bukan group, sorry, individual. Go to, kat mana saya letak? Kat atas sekali. Essay assignment, yes. Okay, DPH C43 essay assignment. So if you click on this, dia punya due date is 10th July. Okay, kamu ada 4 minggu lagi, lebih kurang. So write 300 to 500 words. Write a summary from these 2 essay. Ada 2 tajuk kat sini. So basically kat sini saya dah sertakan link to articles, detecting drug abuse in sports and juga the chemistry of smells. So you have to write only 300 to 500 words, about half a page, ataupun kalau 500 basically 2 perenggan lah, 1 perenggan ataupun 2 perenggan essay worth half a page ataupun almost a full page of paper. Basically kamu perlu, if you click on the link, you will be taken to this RSC articles. So what you need to do adalah kamu perlu ringkaskan, summarize. Tulis satu ringkasan of this article. Ini kamu kena baca dulu and then ringkaskan. Ambil isi penting. Sama macam kamu buat SPM dulu, perlu tulis summary kan? Dalam bahasa Melayu kena, dalam bahasa Inggeris. Tapi saya cakap tentang saya punya dulu. Probably sekarang masih ada lagi tulis summary kan? I think so. So find the isi-isi penting. Tulis isi-isi penting tu, olah dengan ayat kamu sendiri dalam 300 hingga 500 patah perkataan. Okay, so kamu boleh discuss. Yes?
Setiap link tu nak buat 300 ke apa?
No, pilih satu saja. Write one summary.
Oh, okay.
Okay, so choose one. Mana-mana yang kamu nak. Kamu boleh discuss dengan kawan kamu. And then baca satu artikel dan tulis satu saja. Okay, good question by the way. Saya pun nampak saya punya tak clear kat sini. Saya punya instruction. So pilih satu saja artikel and then tulis satu summary for that one article. And then minimum is 300 words, maximum is 500. And then kamu boleh kamu upload the PDF of your essay. Kamu boleh tulis dalam Word ataupun tulis gunakan tangan. Janji in the end kamu convert dalam PDF and then upload lah dalam iTel ni for grading. Okay, so kamu ada lebih kurang 3 hingga 10 Julai. Lebih kurang 3 minggu lagi lah untuk buat essay ni. Okay, ada soalan tentang your assignment ke for your dalam chapter ni tak ada kan? Oops, sorry. Okay, so kalau tak ada apa-apa, terima kasih. Tak sampai sejam. Please, if you have any problems dengan assignment, contact saya. Kalau tak tahu macam mana nak buat your group assignment infographic, your gas problem ataupun your essay ni, tolong contact saya. Okay, because all of this will be a part of your grade. Okay, some will be 10%, ada yang 15, yang group work 20. So make sure kamu buat, kamu submit so that this will be your grade. Sebab kita tak ada final exam our module. Okay, and lastly hujung semester nanti bila dah habis, kita akan buat a final test, which is another 30 MCQ question. Okay, so kalau tak ada apa-apa, terima kasih. Thank you for joining. See you lusa nanti. Thank you all.
Okay, sir. Thank you.
Thank you, sir.
Bye.
Thank you,
Bye-bye.
sir.
Thank you, sir. Thank you, sir.
Thank you.
Bye.
Thank you, sir.
Thank you.